This is a recap for Monday, March 29th. Today in class, we had a little bit of a different period because we explored an idea before really learning about it, and we did that through Desmos. So if you are watching this because you missed class and you want to get caught up on what we did, then you go to the stream and you play the game on Desmos, and I'll go there and show you. So you click on this link, and it takes you to land the plane. And so you put your name in, or your name should be in because you're logged into your Chromebook. And then you start trying to do this game. And so I'm not going to explain the game. I didn't explain the game in class. In class, students were able to ask questions and work with each other, but I'm going to just stop that part of the demonstration right there and just say do your best and come up with questions, and you can come to office hours and ask me for help if you'd like. I will give you a little heads up that by the time you get to card 4, it gets quite a bit more difficult, and especially card 5. So if you get a little confused there, then you're in good company with a lot of the rest of the class. It was a bit confusing. And then what we did in class was, so actually if you're watching this, I want you to pause the recap and do this activity for 10 or 15 minutes and then come back and finish this recap. All right, so hopefully you did the activity. Maybe you got stuck, maybe not. But what we did after this was I went to Desmos, different Desmos, a Desmos graphing calculator, and then I did a couple of demonstrations. So what you needed for that game is you needed to be able to control a line and know where the line was going to point and where it was going to point from. So a basic line is y equals x. So notice how that just popped up there on the screen. And I also want to show you a table. So I'm going to show you a table and how we would get points on here. So y equals x means that the y value is equal to the x value. So if I put in 0.44, that's on the line. If I put in a 0.35, that's not on the line because 3 does not equal 5. So I would have to put 3. This is this table is the x value and the y value. We did that before the spring break on graphing. So if you need to go back and review that, that's fine. We can even go into the negatives, -2 and -2. But in the game we played, the lines went at different angles. So we could change that angle and say y is equal to 2x and see how it makes it steeper. And what this is saying, if we think of it in a table form, is that when I choose any x value, like let's say I choose 2, then this says right here that I double that x value, and that's my y value. So that's 4. See how that put that on the line? So if I take an x value, let's say 1, double it to 2, then I'm on the line. And anytime I take an x value, for example 3, that's going to be 6. -2 doubled is -4. And so these are all lining up on this black line right here. And if we want to put another equation up here, we could say that y is equal to the opposite of x. And watch what that does. So if I want to make a table for that, then every time I choose an x value, I have to choose the opposite of it. So 4 and -4, or -2 and 2. As long as these numbers are opposite of each other, they're going to line up on this line. -3 and 3. You can even do fractions. 1.5, 1.5, and -1.5. So we talked about in class that there are really 4 different ways to talk about the idea that we're talking about. We could say it, for example, y equals 2x. I could just say every time you have a number, you double it, you get a new number. That's the idea. We can write it in equation form, y equals 2x. And we're kind of familiar with that, like 2x, that's like twice as big as something. We're probably not as familiar with a table, which is right here, of choosing x values and figuring out y values and organizing them in a table. And then the 4th way is to actually draw it on the coordinate plane. And the last thing I'm going to talk about is how to move it out of the origin. So notice that all these lines are going through the origin, but if I do this, y is equal to 3 times the number, but we're also going to add 5. Watch what happens. Then it goes up above all these other ones. I want to get rid of all the other ones so we can just focus on this one just for a second. And notice how all these other lines went through 0, 0, but this one does not. So it gets moved up 5. And watch what happens when I change this to a 4. It moves it straight down, 3, 2, 1. That's just 3x, 0, -1. We'll speed this up a little bit. We'll do -10 and see how it moved it. It looked like it moved it over to the right, but really it moved everything straight down. And if I want to go the other direction, so this -10 right here, or whatever number I put in here, like let's say I put a 4, it's going to move it right there. See how it moved it right to there. So that's when x is equal to 0, y is equal to 4. If I wanted to move it up to here, I would just change this 4 right there to a 20. And there it is right there. If I want to change the direction that this line is rotating, think of a clock, I want to rotate it, then I change this number. I can even make it a fraction. Make it really flat. Make the fraction 1/10, and it's very flat. Or I can make it really steep by making the whole thing 100. It's almost straight up and down. So whatever gets multiplied by the x value rotates the line, and whatever we add moves that up and down from the origin. All right, and that is a recap for Monday, March 29th.